Hi, my dear intermediate students, MPC, BPC students, CBSE students, plus one, plus two, and all NEET and IIT long-term, short-term aspirants. Grand welcome to BMS physics classes for NEET and IIT entrance examination coaching. This is Mr. Bhanamurthy. Thanks for joining with me. Now, in this video class, I'm going to project some important information. I hope this is maximum helpful to the students for their upcoming entrance examinations. Wishing you all the best. If you like this video, please do like, share and subscribe. Now in this video class, I'm going to project intensity and potential formulas concepts for different aspects in different situations. Very important. Now in an upcoming mains entrance examination, in every shift we are going to explain, we are going to expect one question from this video class. And for NEET students also, we can expect one question from these topics. Now today I'm going to explain. Wishing you all the best. Now very first concept I am giving, we are expecting a topic here. Due to a point charge, according to Coulomb's inverse square law, we can find out intensity and potential at a particular point due to a point charge, small minute point charge. So the charge value is given there, Q value, and the distance from the charge also is given there. Then at a point P at a distance R, we can find out the intensity. In examination, they may give charge and distance. Charge is this one and distance is this one. Okay, Q and R given. We can find the intensity. So direct formulas I am giving now. I'm not giving derivations. Okay, this is a not correct time situation to give the derivations. Okay, when you join our institution in the long term, we can give each and every derivation for all formulas and concepts. Okay, intensity at a point 1 by 4 pi epsilon naught Q by R square. So E equals to 1 by 4 pi epsilon naught value 9 into 10 to the power of 9 into Q by R square. Just Q and R values are given there. Okay. So potential also is given very clearly here, Q by R, that is. So intensity Q by R square, potential Q by R, that is the difference. Okay. So we are expecting, BMS sir is expecting one question in one of the shifts or in all shifts. We hope this examination, this question may come in all shifts for main students as well as for NEET students also. Let us hope for the best, right? Next concept is, such type of beautiful concepts will be there in each and every chapter. Nearly 40-50 concepts will be there. Okay, if you go through all those formulas and concepts, definitely you can achieve your goal. You can get successful rank. You can get succeeded in getting getting ranks. Okay, so now due to distributed charged wire, now previous case only point charge according to Coulomb's inverse square law. But in this case, distributed charges, okay, infinite charge is present on the wire here. They are selected some wires here. According to Gauss law, we can explain these concepts, okay. So Coulomb's inverse square law is not not enough to derive these situations of intensities and potentials. So Gauss law also predicted his own rules to solve the problems. Okay, so over distributed charges, we can find out intensity and potential. Now we are considering a wire having in charge Q, length L, and linear charge density. I have given clearly linear charge density means charge by length. Okay, charge per unit length of the wire. So lambda value means linear charge density. They will give that value in the examination in question. Now intensity at this point at a distance, perpendicular distance r from the wire is E equals to lambda by 2 pi epsilon naught r. Lambda is given, r is given, 1 by 2 pi epsilon naught value 18 into 10 power 9, my dear students. That is constant value. So lambda and r values are given. You can calculate. Very simple formula. Okay. So it is your duty to recognize all these formulas before to write an exam, before going to examination hall. Okay. So memory power is very, very important for the students. Okay. Now potential value, it is a very well known formula minus integration of E into dr. If you integrate that formula intensity, you will get potential minus lambda by 2 pi epsilon naught into log r, because 1 by r integration is log r, right? So a distance they will give 2 meters, log 2 you can substitute there. Okay, log 2 value you know, then lambda also is given there. 1 by 2 pi epsilon naught value 18 into 10 power 9. Okay, this is the information I'm giving. Okay, potential and intensity due to charged wire also finished. We are expecting that one also. Now, beautiful concept now it is due to distributed charged distributed charged spherical shell of radius r, charge q, and surface charge density sigma here. In the previous case, linear charge density, it is surface charge density. Okay, the charge is uniformly distributed. Okay, distributed charge spherical shell it is. Its radius is r is given, capital R, and the distance small r from the center. Outside, of course, it is. Now, we want intensity inside the spherical shell, inside anywhere we can find out, okay, not only at the center, but anywhere. Suppose if radius of the shell is given 10 centimeter. Now, intensity at the center they may ask, at a distance 2 centimeter they may ask, at the distance 3 centimeter, at a distance 4 centimeter. So, within that 10 centimeter radius, they may ask at any point. Okay, inside at anywhere, intensity is 0 there, because there is no charge inside. Okay, charge resides only on the outer surface. That is important point. Okay, so intensity on the surface is 0 inside. Okay, on the surface now. On the surface means q by r square, q by r square, because ray q, charge q, I'm giving here with this q. This is the charge. I'm writing with the pen here. Uh, charge q is given there. Q charge is given there. Okay, so charge q is present on the surface, then the radius given, q by r square is a formula. And if q value, actually I written sigma here, so q by 4 pi r square, that is the surface charge density. Then from that we can find out q value we can find out from that, then substitute here. So q equals to, actually q is equals to sigma into 4 pi r square, you know, sigma into 4 pi r square. You can substitute that value here in this formula. Then sigma by epsilon naught, you will get it. Intensity outside, now I want intensity outside. Outside means the distance is given there, small r, sigma q by r square, small r square. Then if you substitute q value here, then 4 pi r square gets cancelled. Then sigma by epsilon naught is equal into capital R square by small r square. My dear intermediate students, MPC, BPC, IIT, NEET aspirants. So this information is valuable to you. I hope everybody is observing this video class. Okay, now some experienced tuitions are required for the students to understand all these concepts now, because it's not that much of easy to explain each and every concept. It's only possible for experienced tuition masters. Okay, individually you have to arrange tuitions for your kids. This is my suggestion to the parents. Okay, so potential inside anywhere is q by capital R. And if you substitute q value there, 4 pi capital R square, you will get 1 sigma by epsilon naught. Then integration. How can you get log R here? Because I'm scrolling it up here now again. Intensity inside 0, but here inside is log R. Okay, 1 by capital R is integration is log R, and of course it is minus. Of course it is minus. Okay, so minus integration of E into dr. According to that formula, we can get minus sigma by epsilon naught into log R. Okay, integration of that value. Okay, so 1 by r integration is log R. That's why I'm giving. Okay, of course, we cannot expect this. We cannot expect this here. Just you observe q by r. Okay, so potential on the surface is also same. Potential on the surface is also same formula, q by capital R. Inside anywhere and on the surface of a spherical shell, potential is same. Okay, so potential at the center, potential on the surface, potential anywhere inside. everywhere same it is. Okay, equipotential surface we can call it as. Okay, potential at any point is same inside and on the surface. Okay, now third one is a potential outside the shell. Outside the shell also they can ask, because a small r is given there, q by capital small r, by substituting q value there, and integrating e out, it's integration. V out is equals to minus integration of e out into dr. Okay, this is the formula. E out into dr. E out formula is given there, then integrate that formula, you will get this formula. Okay, now that is important. So my dear students, you observe the formulas I have given in boxes. Due to an electric dipole at any point r comma theta, dipole concept we can expect, my dear students. Very, very important concept. In 2024 also, in every shift they asked one question from this dipole, and in phase 1 and phase 2 also. For NEET students also, dipole concept is most important for an upcoming entrance examination. They're asking this question frequently for NEET aspirants. Okay, intensity at any point or distances angle theta here from the center of dipole. So dipole is a combination of negative and positive equal and unlike charges separated by the distance to A. Okay, so this is the distance to A between these two charges, and this distance is A, this distance is A. Okay, now from center to any charge is A. Now intensity is 1 by 4 pi epsilon naught. At this point E, I represented point P there. At point P, the intensity is 1 by 4 pi epsilon naught P by R cube into under root of 1 plus 3 cos square theta. My dear students, P for what here? P for dipole moment. I am writing here dipole moment. So dipole moment it is. Okay. So dipole moment P is nothing but one of the charges into distance of between the two charges. That is the length of the dipole. So we can substitute P value Q into 2A. Okay. 2A is the length of the dipole. I represented in the diagram. Okay. Potential also 1 by 4 pi epsilon naught P cos theta by R square. So if they give angle and distance, you can substitute. Okay, and the charge also they will mention, and the length of the dipole they will mention. So dipole moment you can calculate by separately and substituting there, you will get the formula. Now intensity on axial line. Axial line means how can you get axial line here? I am scrolling it up. Now I am drawing the dipole here. So this is a dipole. Okay, now this is the length of dipole, and the line extending is called as axial line. Okay, on axial line at this point we want now intensity on axial line. Okay, so its direction is from minus q to plus q. Recognize this point. On axial line of a dipole, intensity formula is 1 by 4 pi epsilon naught 2p by r cube, because theta value 0. Because the previous diagram, I'm scrolling it up, you observe the previous diagram and this diagram. So in this diagram, angle is 0 on axial line. So then you can substitute there, then you will get 2p by r cube. Okay, my dear students, very important formula it is. And potential on axial line, VA equals to 1 by 4 pi epsilon naught P by R square, because cos 0 is 1. Okay, nice. And intensity on equatorial line. Equatorial line means I'm drawing equatorial line also here. This is a dipole here, minus and plus here. And this is the length of the dipole. This is the center of the dipole. Now I'm representing this with green color pen. This is called as equatorial line. At a distance R, point P is expected. Their intensity direction. All intensity direction is from plus to minus. Recognize this point. Intensity direction from plus to minus. Direction also is very important because it's a vector quantity, right? So intensity on equatorial line P by R cube, because the distance difference between those two, that is 2P by R cube. This is P by R cube. Okay, you can differentiate. Okay, now potential on equatorial line is 0, because in that formula cos 90 is 0. So at any point on the equatorial line or bisector line, potential is 0. We can expect. Suppose if it is a dipole, at any point on equatorial line like this. So here, everywhere potential is 0 on bisector line, right? Now, Next one is intensity at the center of dipole. Intensity at the center of dipole means this is a dipole here, this is a length of dipole. At the center of dipole intensity, this is minus q, this is plus q. In order to find intensity, we have to expect plus q naught here, plus 1 coulomb here, unit positive charge. At the center, in order to find intensity, we have to expect unit positive charge there. Then intensity at this point due to negative charge is attraction here. This is E. And intensity due to positive charge and due to plus and plus here, what repulsion is there? Okay, so intensities. These two intensities are in the same direction. So therefore, E net is equal. So this derivation point I will give in the academy, in my academy. If you join in my institution, each and every concept, explanation, derivation will be given to you. So E net is equals to 2 times 2 into E. E value is what? 2 into 1 by 4 pi epsilon naught into Q divided by A square, because distance is A given there. Okay. So this is the formula I written there, 2Q by A square. And potential on equatorial line at any point is 0. So my dear students, this is my way of explanation. Because it's a very video, short time is there. That's why I could not explain each and every topic now. Nearly 40-50 concepts will be there in each and every chapter in physics. So it's a tough subject. It plays an important role in deciding your rank in NEET as well as IIT mains. Okay, wishing you all the best, my dear students. If you like this video, and you please do like, share, and subscribe. And for getting more and more information, I'm giving the link in the below description box. So you just click that link and you will get maximum information from this academy. So thanks for watching my video classes. So wishing you all the best, my dear NEET aspirants and IIT aspirants. And for NEET students, there is a sufficient time, 4 months time here from today onwards. You join in our institution, you can crack this ranks in entrance examinations. Okay. Thank you very much. See you. Bye. In the next video class, I will give more and more information regarding next chapter. Okay. Bye.